In this lesson, we are going to study about probability. How do you express a probability? The probability of an event is a number that describes the likelihood that an event will occur. So what is probability? It is actually a number that describes the likelihood of an event that will occur. It ranges from 0 for an impossible event. So if the event is impossible to happen, the probability is 0. And if the event is definitely going to happen, then the probability is 1 for a certain event. So the probability ranges from 0 to 1. 0 being impossible event and 1 being certain event. We write the probability as a fraction. So probability of an event. How do you read this? Probability of an event is equal to the number of possible outcomes divided by the number of favorable outcomes divided by the number of possible outcomes. We will try to understand this by doing examples. So how do you find the probability of an event? It is a fraction of the number of favorable outcomes divided by the number of possible outcomes. Let us look at this example. A bag contains the number of cards shown above. Let's look at these cards. Joe draws one from the bag without looking. So he is pulling out a card from this, one card without looking. Find the probability of getting a prime number. So we know a prime number. Prime number means the probability of getting, P of prime means the probability of getting a prime number. So we have to find out, if he draws one card, what is the probability that he will pick up a prime number? We know prime numbers are 2, 3, 5, 7, 11, and so on. Now let's look at this pack of cards. First of all, how many cards are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 10, sorry. So there are 10 cards. So in a fraction, what is the number of possible outcomes? So since there are total number of 10 cards, so the denominator is 10. Now he has to pull out a prime number. So how many possible prime numbers are there? 1, 2, because there are 2 cards numbered 7, and 7 is a prime number. So there are 1, 2, 3 is a prime number, 2 is a prime number. So there are 4 prime numbers. So the possibility of a prime number card getting picked up is 4. So 4. So there are 4 favorable outcomes. 7, 3, 2, 7. Divided by, there are 10 cards. So there are 10 possible outcomes. So 4 over 10 is the probability. The probability of getting a prime number is 4 over 10. Or, if you simplify this, 2 over 5. This can also be expressed as a decimal. 2 over 5 as a decimal is 0.4. Or as a percent, it is 40%. Because how will you change a fraction to a percentage? 2 over 5 multiply by 100. And that is going to be 40%. Mia tosses a number cube. You know how a number cube looks like. What is the probability that she does not toss a 4? If she tosses a cube, we are finding the probability of the cube landing on a number which is not 4. Not tossing a 4 is the complement of tossing a 4. So not tossing is the complement of tossing. Let's look at this. There are two ways of doing it. There are 5 favorable outcomes. Without the 4, what are the possible numbers which can land up? That is what we are looking for, not tossing a 4. So the cube can land up at 1 or 2, 3, 5, 6. So there are 5 favorable outcomes, not tossing a 4. So there could be 5 numbers which can come up without the 4. So 5 favorable outcomes. And what are the possible numbers in the cube? So there are 6 possible numbers. So the probability of not 4 is 5 over 6. So the probability of not tossing a 4 is 5 over 6. Let's look at the same problem in another way. Mia tosses a number cube. What is the probability that she does not toss a 4? Not tossing a 4 is the complement of tossing a 4. So let us find out what is the probability of 4 coming up. Use the fact that probability of an event plus probability of not an event is always 1. Remember this. So let us first find out what is the probability of the cube landing a 4. How many 4s are there in the cube? Only 1 4. So the favorable outcome is 1. And the total number of outcomes are 6. So the probability of the cube landing with the 4 is 1 over 6. And the probability of not landing with 4 is 1. So if we substitute in this P of even, probability of 4 is 1 over 6 plus probability of not an event is equal to 1. So if we are finding not 4, so P of not 4 is going to be 1 minus 1 over 6. And we learned how to subtract fractions, so it's going to be 5 over 6. This is one way of doing it. This is another way of doing it. In example A, the cards one, what is the probability that Joe draws a 5? So we are finding the probability of drawing 5. Total, how many cards are there? 10. We are looking for 5. How many cards are numbered as 5? There is none. So the it is 0 because we don't have a card with the number 5. So 0 divided by 10 is 0. So the probability of picking a card which is numbered 5 is 0. Impossible. That's the answer. Give the probability in example B as a decimal. So what is example B? Let's look at example B. The probability of not tossing a 4. How much was that? 5 over 6. So we have to give this number. Give the probability in example B as a decimal and as a percent. rounded to the nearest tenth of a person. So the probability of not tossing a 4, not 4, was 5/6. He wants this number as a decimal. So 5/6 as a decimal is how much? It is 0.83. So as a decimal. And as a percent, 5/6 will be, or 0.83. If you want to change this to a percentage, you multiply by 100, and it's going to be 83%. So the probability of a number which is not 4 when you toss a cube will be 83%. Cards numbered from 1 to 50 are placed in a box. Sumi picks 1 without looking. Find each probability as a fraction, decimal, and percent. So let's look at the first question. The probability of picking up a number which is less than 25. So we have, when we pick up the card, the number should be less than 25. So what is the probability of picking up a number which is less than 25? First of all, what are the total number of outcomes? 50. Now in a card numbered from 1 to 50, how many numbers are less than 25? How many cards will have numbers less than 25? It will be, so the cards which are numbered less than 25, you will have 24 cards whose numbers are less than 25. So the favorable outcomes will be 24. So the probability of numbers less than 25 will be 24/50. Or if you simplify this, it's going to be 12/25 as a fraction. As a decimal, we learned how to change fractions to decimals. It is going to be 0.48. And as a percentage, you multiply this by 100, it becomes 48%. Let's look at another problem. Cards numbered from 1 to 50 are placed in a box. Sumi picks 1 without looking. Find each probability as a fraction, as a decimal, and as a percent. The probability of picking up a 2-digit number from the card. The probability of picking up a 2-digit number. So first of all, what are the total possible outcomes? Because there are 50 cards, 50. Now, how many cards will have 2-digit numbers? We know that 2-digit numbers will start from 10. So 10, 11, 12, 13, 14, and so on up to 50. So what is the number of cards which have 2-digit numbers? They will be 41 cards. So 41/50. Or if you change this to fraction, it's going to be 0.82. Decimal, 0.82. And the percentage is going to be 82%. Let's look at this. Cards numbered from 1 to 50 are placed in a box. Sumi picks 1 without looking. Find each probability as a fraction, decimal, and percent. Probability of picking up a card which is not a multiple of 10. Picking up a card which is not a multiple of 10. What are the multiples of 10? The multiples of 10 are 10, 20, 30, 40, 50 in a card of from 1 to 50. So these are the multiples of 10. But we are looking at picking up a card which is not a multiple of 10. So now, total possible outcomes, 50. Now, how many cards are there which are not multiples of 10? The multiples of 10 are 1, 2, 3, 4, 5. So we have 5 cards which are multiples of 10. So the number of cards which are not multiples of 10 will be 45. So 45 over 50. Or if you simplify this as a fraction, it's going to be 9 over 10. If you write 9 over 10 as a decimal, it's going to be 0.9. And if you write this as a percentage, it is going to be 90%. Cards numbered from 1 to 50 are placed in a box. Sumi picks one without looking. Find each probability as a fraction, decimal, and percent. Reasoning. Let's see. Is drawing an odd number more likely than, less likely than, or as equally likely as drawing an even number? Explain. You have a deck of cards, so 1 to 50. Drawing an odd number or drawing an even number, will the probability be less than drawing an even number? Will the probability of drawing the odd number card be greater than even number, or it will be the same? They will remain the same because the odd numbered cards and the even numbered cards are going to be the same. So equally likely, there are 25 odd numbers and 25 even numbers. So the probability of drawing an odd number will be equal to the probability of drawing an even number.